So again, welcome to all our attendees, and we are here today as Eurisy to support and to basically inform about the challenges of the blue world. This webinar series has been co-organized by the European Space Agency and Eurisy. This one is the second of a series of 3 webinars and will be focused mostly on secure transports and communications. The previous one was about the exploitation of marine resources, and we focused mostly on aquaculture and fisheries and the tracking of illegal fisheries. And there will be another one on the 25th of February, so on Thursday, and it will mostly be focused on maritime special planning. So I introduced already a little bit the series of webinar. I believe that the majority, I hope that actually the majority of you was with us also last time and will be with us next time. But just the purpose is to support the stakeholder consultation initiated by the European Space Agency. And of course, a little bit about the Blue World Task Force will be presented just after myself and my presentation. I already went through a little bit the different topics of the webinar. The idea is to engage as much as possible the final users, so you, the actors of the maritime sector, to tell us a little bit more about your current technological challenges, your current needs. So for the European Space Agency, develop new programs that can be really like addressing your needs. A little bit about the logistics of the webinar. So please use as much as possible the chat to share with us your comments, your questions. We will be happy to gather them all and to pose it to our speakers at the end of the different presentations. Of course, we will also share with you the link to the survey that we are actually promoting with this series of webinars, so you can take the survey and tell us more about your challenges. I will go on by presenting briefly Eurisy. So Eurisy is a non-for-profit association based in Paris, and as you can see in this slide, is basically composed by more than 15 among European and let's say international space agencies. We are mandated to bridge the gap between space and society. We do so with an approach which goes from the exploration to existing and operational satellite-based solution, and we do raise awareness on the benefits for a diverse set of users communities. We gather the stories of early adopters of satellite-based technologies, and we promote them through the relevant communities. We do act as matchmaker, bridging the gap between the users, communities, and the service providers, and supporting also the final users in getting to know how to use the satellite-based solution, which operational services are out there, and how they could benefit from a proper integration into daily workflow. We do also work as advisor for policy and decision makers. We bring back feedback of final users to them in order to fine tune and to develop new policies that include the satellite data and satellite data sets as a source of information to have more informed decision-making processes. We do act based on different thematic areas, one of them being a space for maritime. We have also like additional topics which range from future health to culture to smart cities to sports, for instance, of course, trying to identify the best solution per each different domain, and again promoting those solutions towards the right communities, as we do it for the space for maritime. Indeed, the objective of this initiative, in line with the approach that I mentioned earlier, is to identify, to map the stakeholders of the specific sector to better understand their needs and challenges, and to favor the interaction with the service providers. In this sense, we promote operational satellite-based solution, and we report back to the institution's feedback of the users. We do so by gathering again what we call the user cases, and I would like today, in order to set the scene, to just introduce two of them. The first one being a success story about the German Central Command for Maritime Emergencies, which is a joint institution of the German federal government and 5 German coastal land states. The CCME basically ensured a safe navigation in the area of North and Baltic Sea, and manages all kinds of emergencies, including on icy accidents. One of the most common effects of those accidents at sea are oil spills, which indeed represents let's say, very hazardous threats for the marine ecosystem, but also for the environment, but also for the coastal economies that can impacted quite heavily by oil spills that are reaching, let's say, beaches. We can just imagine what can happen in summertime when and if some oil is arriving really close to the coasts. In this regard, the CCME, to effectively address this challenge, use the Clean CNET. Clean CNET is a service provided by the European Maritime Safety Agency, EMSA, which combines satellite SAR, synthetic aperture radar images, and GNSS data to provide information on oil spill and also on the movement of vessels and their detection at sea. Basically, this solution can provide all the different units on the shore, so on land, with an alert when an oil spill is detected. And the CCME in this case, but also other national authorities, so for other different countries, because currently this service is used also by other countries, can basically react, can deploy the operational unit much more effectively than without this kind of service. We can only imagine. Otherwise, the patrolling and the control should be done randomly through helicopters or other measures. And the result is that the CCME, through this solution, could significantly improve the surveillance capacity, and also could manage way more effectively the teams, the emergency teams on the let's say on the spot, with a significant savings thanks to a more precise action. So this is the kind of user stories that we are gathering and promoting. The second one, also related to transport in sea, is the one related to the Finnish icebreakers. So in this case, the user has been represented by the Finnish Transport Agency, which is responsible to ensure the Finnish transports, being them on railways, on highways, on waterways. And they need to ensure the smooth management of those transports all year round. And the FTA is responsible for coordinating the transport in this case, and for our interest, on waterways. For all the Finnish 45 different ports. During winter times, the fleet of the ice breakers will be, as you can imagine, very busy. Cleaning ways and into the different ports and guiding merchant ships through continental waters. I would like only to highlight that in Finland, about the 90% of all the import and export goods is transported by sea. So you can imagine the impact of maritime transports for the country, and is the only country that in the world where all ports freeze during winter times. So in winter, the operation of the icebreakers is key for the country, and the need to keep the ports open and the navigation fluid is a vital challenge for the country's economy, and the need to monitor ice condition is not new. So it's clearly like a long time that Finland and the northern countries are doing so. But in the past, open lines have been monitored with, again, helicopters and radar into the different icebreakers. However, this reach was quite limited into couple of miles within the reach of the vessel itself. With the development of satellite services, the basically FTA could reach let's say way wider, I don't want to say territory, because indeed this is in IC, but indeed spectrum of sea. And since early 2000s, FTA increased the usage of satellite data, offering like information on a large portion of sea. And this also is very useful because the information would be given day and night and in all weather conditions. So the increase, not only on the quality of the information that was provided, was completely improved, but also on the disposition of those information was very much improved. And in this case, the result has been quantified in about €1 million savings in terms of fuel consumption for the fleets. And in general terms, there was an optimization of the routes of the fleets. And these are concrete material results that has been achieved thanks to the introduction of integrated satellite application into the daily workflow of the unity of the Finland Transport Agency. So I just wanted to present those two user cases because I believe that are very important and in line with the topic of today. Right now, I thank you everybody for the attention, and I will I will provide the floor to Isabel, the next speaker here in line. Again, for those who participated last time, it's likely that you remember she is the head of Member States Relation and Partnerships Office within the European Space Agency. So Isabel is in charge with the relations with the 22 ESA member states, towards which she ensures a coordinated corporate information, and she's also in charge for the implementation of transverse initiatives such as the regional initiative within which the Blue World Task Force is included and developed. She will today introduce again the Blue World Task Force and the stakeholder consultation for which we are here today. So Isabel, please, the floor is yours.
Thanks, Annalisa. I put my camera on, but I will switch it off after, just that you see that I'm here, because the connection are not always very good, so it's just for you. So thank you for being there. Thank you, Annalisa, also for the examples that you have shown. So I will be quite short because I will just give some introduction of why we are doing that. Just goes to the next one. Do you see the next page or not? Yes. So sorry for the one that were there last Thursday. I will more or less repeat, even if I never say twice the same thing. So ISA, we are an intergovernmental organization. So we are constituted by our member states for our member states, with, of course, program for the European Union. But basically, we are working for our member states. So 22 member states. A budget that is in 2021 around 6.5 billion euros. So this is 12 euro per European per year. And for this amount, we have program in all the areas of space, from science and planetology to application, launchers, technologies, and so on. What we call the Blue World Task Force, it's part of what we have developed since a few years, that is a regional approach to support the member states that have the same type of challenges in a region of the world. Region not in the terms of administrative region, but really a geographical area. Concerning the ocean, we started that in 2018-19 with the first request of member states. We have done a mapping exercise in what is called the Concurrent Design Facility in 2019 to have an overview of the programs that today are addressing the maritime activities at large. The task force itself gathers representatives from the member states interested. We have 19 out of the 22 member states that are part of the task force, plus one associated, and of course, these are experts. And the aim of these task forces is to identify what would be the capacity gaps between the needs of the sector and the space project and activities that are provided. So we are really there to support the preparation of the next programs, addressing in a bottom-up approach the needs of the sector. And this survey that we are talking about, a survey questionnaire, was suggested indeed in the frame of this task force. So just the regional approach. It started more or less with the Arctic, which was in 2012, and then we had the task force in 2016. Sorry, Blue World is the next active one that became active end of 2019 after the last council at ministerial level. It started with specific requests from Portugal to work on the Atlantic and from Greece to work on the Mediterranean Sea, and we decided to group them together. And with the other member states, they addressed that they wanted to see also Black Sea, Danube, the Baltic, the North Sea, and the Arctic Ocean. And it doesn't mean we would not go further, because we have some of our member states, for example, France, that has also territories in the Indian Ocean or in the Pacific Ocean. Or so it's really addressing the challenges that are faced in the oceans or the seas. And we have also some initiative in force or starting for the Alps, for Africa, and for Antarctica. So the survey itself, it's really collecting the views of the maritime users to be able to better work with them, or better understand the needs and better work with them. It was disseminated by our member states through their network, and we have also done dissemination within our own networks, and Eurisy and some other actors like NGOs have also done their dissemination. So there is no limit in the one who can answer. It's really addressing all types of users. from from science to national authorities in charge of maritime surveillance, for example. There are 28 questions. It shouldn't take too long if you didn't yet answer to it. Some are multiple choice, some are open questions. Some information about you, that we know what type of organization you are, your maritime priorities and the drivers behind. What is also the knowledge that you might have about the potential of space assets. It's not a prerequisite, it's just if you use or if you know. And then whether you would be interested for a follow-up and to engage into discussion with us, either bilaterally or within group of similar users, and whatever comments. The deadline is at the end of the week, normally, but it should not take too long to fill it in. You have the link here on the slides, but of course you can find it on our website, or Annalisa and Eurisy will send it to you if you do not have it. So this is just in short what I wanted to say. Of course, I will be available for questions later if you wish. Now I think it's good to go to the real examples and real information. I will. Thank you, Annalisa.
Thank you very much, Isabel, for presenting in a nutshell what the Blue World Task Force is and what ESA aims to do with the information gathered through this stakeholder consultation. Indeed, I would like to introduce our first speaker of the day, Mr. Fabio Faraone, who is the head of Technical Safety and Environmental Department within Confitarma. Fabio is a naval and mechanical engineer with a long-standing experience within the Italian Navy. Since 2008, Mr. Faraone is the head of the Naval and Environmental Technical Service within the Italian Confederation of Shipowners, Confitarma. In his capacity at Confitarma, Fabio coordinates the technical units of the organization, and he represents Confitarma also at international fora such as the International Maritime Organization, the European Community Shipowners Association, the European Maritime Safety Agency, and the International Chamber of Shippings. Mr. Faraone today will introduce us the maritime autonomous surface ships and the technology and regulatory framework around autonomous shipping. I will close my camera and I will pass the floor to Fabio. So the floor is yours.
Okay, perfect. We can thank you for your introduction. Let's talk about this autonomous ship. Okay, the matter is, do we know what, when we talk about an autonomous ship, do we know what we talk about? Because it's a very generic word. The matter is that we have just an experience. On the 3rd of December 2018, there was a test was carried out in Finland. The ship, the name of the vessel is Falco, and they carried out a trip in a fully autonomous way. But the matter is another. We don't talk about the autonomous ship, but we talk in our when I say we talk, as Annalisa said, we talk in IMO, in International Maritime Organization. So we talk about maritime autonomous surface ship, MAS, and we refer to different degrees of automation. Because at the beginning of the story, I was in IMO and I was curious, but we started by a paper, a single paper, A4. But the beginning, the job, the IMO decided to define with the definition of different levels of automation. So very shortly, starting from a ship with the seafarers on board and several processes in automation, then a ship with the seafarers but controlled from another point, then a ship without any people on board but controlled from another place, and finally a fully autonomous ship. But how we arrive to this? The process is not simple, and the story began in 2018 in London, at IMO, and the target was to obtain a regulation, but how? With a regulatory scoping exercise, identifying the different aspects that was necessary to cover with the regulation. And for doing this, the main regulatory frame was the Maritime Safety Committee. But as I said, the shipping is a very complicated reality, so was involved also the legal committee and also a facilitation committee inside IMO to coordinating all these rules that was necessary to follow. As I said, in this exercise were carried out different levels of automation, as I said, and I mention this just to follow the process, but I've spoken about it previously. Then what we have to pay attention, because the problem of the mass operation is that you have to cover different aspects: the human element, the technology, and the operational factor. And for this, the plan was to finish with the regulatory scoping, the exercise in 2020. But as we know, there was some complicated matter. Why? Who is involved? As I said, is involved the Maritime Safety Committee, because the Maritime Safety Committee is competent for the safety, SOLAS, for the collision regulation, correct, for the load lines, how much cargo you have, then the seafarer, the STCW, and the search and rescue. So there are a lot of implications in conducting a ship worldwide. For this reason was involved also the legal committee. The legal committee, you can see the list, is a very long list with all. There is also the Nairobi Convention. There is everything inside this list, and it's a very complicated matter to follow. What happened in these 2 years? We arrived in September on the 2020, but according to the pandemic situation, this item was postponed to the next Maritime Safety Committee 103. So what happened? We have to go back to the Maritime Safety Committee 101, and the scoping exercise was one of the items of the committee. What happened? During this committee, the attention was mainly for the glossary and for the definition, because the glossary and the definition are the base of all the regulatory scope. And they arrived to a result. The first result was a guideline for the test of this vessel, and was an interim guideline, but was something to can be used by the early movers. And we arrived properly to these guidelines, interim guidelines. Naturally, was approved, as I said, and this is the situation nowadays. Meanwhile, what happened? Fincantieri made the Vard shipyard made a ship, the famous Yara Viking. And this is a real ship, it's not a toy, it's a ship of 80 meters length, for 15 meters wide, and they started with the test. The tests are divided in 2 phases. The first one is for the loading, for the operation, because it's for containers, so they are checking the functionality of the vessel in the ordinary maneuvers. The second part is related of the tests, is related to the autonomous operation without the crew. So this is the situation of the Yara Viking. What happened at the European level? Because I work with mainly in worldwide situation, and we work with IMO. In IMO, there is the project Horizon 2020, and inside this project there is the project Autoship that was with the target of test on vessel. Naturally, during the following this project, some companies arrived to do two projects and to carry out this project in the Baltic area. Baltic area is a very critical zone. Also, Annalisa spoken about this reality. The North Sea and Baltic area are very, very important field for this kind of operation from different point of view. Naturally, all these operations must be managed, controlled in such a way. How? With the satellites. Satellites are a key role in this matter, but not only on the control. I want to underline how much important is nowadays the exchange of data. Nowadays, not only for the autonomous vessel. Nowadays, we need to exchange really a lot of data for the engine, for a lot of things. So for us to use the satellite is very, very important. I made a small search in internet, and I found that just 3 years ago, there were several troubles with the communication, but in a recent conference, someone said to me that these limits can be superated in a very practical way. Anyway, conclusion, I wanted to stay in the time. Why we look to the autonomous technology? There are several interesting, the slide is not very clear, but is very clear in the view, but is very comprehensive. There are different aspects. We have an increase of the human safety and a reduction of the human errors. On one side, we have also the from the economic point of view, a reduction possible of the personnel. You can increase the cargo capacity and the crew space efficiency. Finally, you can control you can monitor the machinery performances and also the condition of the cargo. Concluding very, very fast, the matter is how the ship owner look to this future. For ship owners, the health and the life of the personnel is the main target. And we have also the second target associated is the protection of the environmental is the second target. Naturally, we are not a researcher, we are not, as we say, the Red Cross, we are in business, but we look to this transition in a very strong way. You have to consider that in the shipping, the changes are not really fast, such in the other business. So, but anyway, we pay a lot of attention to all these aspects. I think that I have finished. I'm sorry if I rush. That's all.
Thank you very much, Fabio, for your very comprehensive presentation and very informative also on the regulatory side. Of course, I invite all the people following the webinar to pose any question on the chat, and I would move to the next speaker in line. So I will present Orpheus Voutiras. I hope that I'm pronouncing your name correctly. Sorry otherwise. Who is an associate associate from the Athena Research Center and the Coralia cluster. So Orpheus holds a Master in Electrical and Computer Engineering from the National Technical University of Athens, and since 2016 is an advisor at Coralia, with a primary focus on activities supporting the growth of the Hellenic Space Technologies and Application Cluster, the C cluster. Orpheus has been actively involved in national initiative for the development of satellite technologies for the blue growth, including the European projects Neptune, new cross-sectoral value chains creation across Europe, and Galatea, grow and accelerate your smart projects in new value chains of the European blue economy. Orpheus will introduce us to the existing technology solution in the field of maritime, and especially for transport and the connectivity at sea. Orpheus, I leave the floor to you, so I will switch off my camera, and I look forward for your presentation.
Thank you very much, Annalisa. So as it was suggested, we are going to present some of the technologies that are being used from a space perspective for tackling the challenge of the autonomous shipping. And with no further delay, I would like first to make a short introduction of the SI cluster so that you get a general idea of the space activities, not only from a technological point of view, but also from a business point of view, what can take place. And some statistics about the Greek blue world, because the SI cluster is being active in Greece, especially. So most of the space applications that are being adopted in the field of blue growth are also adopted in the Greek space sector. So who we are a cluster that has the vision to be a world-class cluster on space technologies and applications. And fortunately, we've achieved that for the past few years. We are one of the 3 gold label clusters worldwide in the space sector. And that's an indication of the cluster management excellence. Here you can see some of our members and the main value chain. And from this point onwards, you can see some indications about the technologies that can be used in maritime and blue growth. For example, you can see that there are indications on the hardware side regarding robotics, aerospace electronics, and advanced materials, but also on the side of operations and the remote sensing, also known as Earth observation. So we have 2 sides here. One is the hardware side, the upstream, as we call it, and the other one is the downstream, which is related to the acquisition of data. And of course, you can see all of the corresponding application areas. In a similar sense, we have members and cooperators within and around the cluster that are related not only to the industrial sector, but also the academic and research sector. Of course, the public agencies. My friend Fabio already showed how important it is to have connections and follow up with the regulatory frameworks and the policy makers. And we also try to get the civil society to also participate in such activities. And here you can see another indication of the ecosystem around the SI cluster, where you can see that there are several conferences and events that take place. I would like to mention, for example, the Copernicus Hackathon, which is a hackathon that uses Copernicus data for challenges such as the blue growth. Regarding incubators, we are happy to announce to you that in a few weeks, the SI cluster in Coralia will present the Greek ESA-BIC that will be established this year. And of course, several accelerators such as Galatea and Neptune that were already mentioned that are focused on using space technologies in the sense of blue growth accelerators. Regarding our services portfolio, it's related to innovation and technology, education, training, policy action, class expansion, advising, networking, and so on and so forth. And one of our main activities is the devising the strategy and business plan that coordinates all of the above activities that we showcase to you, with a lot of technical details and focusing on specific technological challenges each year. Similarly, we create a Greek space catalog with all the capabilities, space capabilities of Greece, and you will see why this is important for us in the next. Now about the Greek blue world. Greece is an aberrant occasion, let's say, because besides its size, both in population and economic terms, it's the world fleet leader in deadweight tonnage lead. So with statistics from 2017, you can see that we have 17% of the world total, with countries like Japan and China following up. And in terms of commercial value of the world fleet, we are third, following the United States and Japan. And as you can guess, the shipping industry in Greece is by far the most extrovert sector of the Greek economy, and pretty important for its GDP too. And here you can also see the corresponding EU statistics in terms of employment. So you can see that around 6 million people are employed in the sector. Sorry, not this is the right one. So around 4 million in this sector, and there is a GVA of around 168 billion. So what we've done in the past is a Space for Maritime.gr study. It's similar to what also Annalisa mentioned before, for what we are trying to do in a EU, let's say, level. We did this actually a few years ago, actually the previous year, I think, yes, previous year, with cooperation with ESA. And we did exactly this exercise, let's say, for the Greek space sector. So the main objectives of our study were, first of all, to identify the needs of the maritime sector in Greece specifically, but of course there was a lot of desk research, let's say, regarding global statistics and events, and not only stay on the level of needs, but also identify specific technical requirements. So, for example, I may need to monitor the weather. This is one need. But a requirement in this case would be details such as, okay, what type of environmental parameters would you like to measure? For what, how long? With what, let's say, spatial and temporal resolution? And so forth and so on. And next, the next exercise for us was to identify existing solutions, technology solutions in the space sector that could cover these needs. So that's exactly where the Greek space catalog that I mentioned in the previous slides comes into play. Here you can see some statistics and the thematics areas of the study. Of course, we had a section that was exactly the same with the workshop we have today, the event we have today, and it was related to transport, communication, logistics, and of course, autonomous shipping. And the results we got were from over than 200 questionnaire responses, 30 interviews, and we managed to get around 118 needs. So the exercise per se and the final results are in the format you can see here. For example, we had, as I mentioned, needs related to the monitoring of currents, as you can see, the wavelength of sea waves, etc., etc. Then we got these needs into specific requirements and identified what type of horizontal or vertical coverage in spatial terms is needed and what type of resolution. Then we also identified the corresponding space solutions, for example, provision of CubeSat constellations for supporting AIS services, for example, or UAVs and satellite images technologies that can be used for the detection of artificial plastic, for example. And then we complemented all the solutions with the corresponding Greek space catalog. So the results can or cannot be seen here. This is a table that aggregates all the mapping of the needs to specific technologies and stakeholders. And here is a more visible table where you can see that, for example, for autonomous shipping, maritime cybersecurity, and in navigation, specific space actors have been identified. And the same has been done for the three types of satellite-based solutions in space, which is Earth observation, positioning, navigation and timing, and communication services. So with that in mind, we go back to the autonomous shipping thematic area that Fabio presented, and you've already seen this slide. It's about the 4 degrees of autonomy. So we start from this level right now, and we are trying to go to full autonomicity without any people on board, ideally. At least no personnel, no people on board. So here are some of the results of this study, but identify specific requirements for this autonomicity. And these requirements are identified by specific technologies that have to be adapted. And these technologies are not just space technologies, but we've accumulated all the corresponding technologies that are related and can be used in parallel with the space sector, because in such cases, we will have to integrate these solutions. So here, for example, you can see that there is a requirement of sensing for the ships. So for a ship to be autonomous, it has to sense its environment. It has to have situational awareness, as we say. To do this, it will need IoT devices, it will need cameras, it will need LiDAR or short-range radar, and it will need Earth observation data. And all of this information has to be aggregated and, of course, be merged and used at the same time. So we shouldn't see isolated the space solutions in this sense. Similarly, the ship will need connectivity, so connectivity of the IoT systems, LoRa systems, communication systems, etc., etc. Another requirement is, of course, digitalization, so digitalization of machinery and equipment, and the provision of a corresponding digital twin of an entire ship or of the subsystems of a ship, because in such cases we can run not only what-if scenarios and investigate the results of specific activities, but we can also help in decision making and planning for autonomous ships. Next category, of course, would be monitoring, data analysis, and smart and cognitive systems. So we've acquired all this data. We also have a digital twin. What do we do with all this? There we're trying to create from data information and from information knowledge. So at this level, we have all the corresponding solutions, but depend on computer vision, big data analytics, artificial intelligence-based situational awareness, learning, and we come here in space solutions again, such as efficient optimal navigation control algorithms and proactive and reactive cognitive systems. And then again, going even further, we need positioning, navigation, timing, so the ship has to know where it is and when, and communication, so the ship has to receive data and, of course, broadcast this data, or not only broadcast, but have specific links with other vessels or the ground and the coast. So here is where GNSS and information relays play their own role, and where telemetry and the telecommand are on the third, let's say, level of autonomicity for autonomous ships. And another indication here of communication is not just vessel to ground or vessel to satellite communication, but also vessel to vessel communication, where vessels work in swarms. And finally, we have other technologies, more generic ones, such as robotic-based maintenance and repairs, onboard automatic 3D printing, UAVs, augmented reality monitoring, and cybersecurity. And at this point, I would like to stress out that these technologies are also used on the space sector. And you can only imagine the experience that is acquired in the space sector, especially on the robotic-based maintenance, let's say, or operations in space for satellites maintenance, for example. And in this case, you can also see how such more hardware-based solutions could be adapted in the space sector. And finally, we shouldn't stay only on the technology, let's say, solutions,
So we might have some problems of connections because I see you now, but I cannot hear you, Orfes. Yes, indeed. Thank you very much. So I think we can, for the time being, actually pretty much well connect to what you would have presented in your last slide in terms of funding opportunities and research and development activities. And in this regard, we actually have Roberta Mugellesi from the European Space Agency with us, and she will present indeed some opportunity opened by the European Space Agency. Roberta indeed is a business application manager within the downstream business application department and the Directorate of Telecommunication and Integrated Application of the European Space Agency. She has been involved as project manager in the development of more than 40 services dealing with transport, maritime, fishing and infrastructure monitoring. And Roberta is also a member of the International Program Committee at the International Astronautical Federation and member of the International Academy of Astronautics. And she will present today the latest project launched by the ESA business application dedicated to intelligent maritime transport and the open calls to which European SMEs can apply to develop technologies responding to these specific needs. I will leave the floor to Roberta.
Thank you, Annalisa. Thank you for the invitation. And so I think this, I'm very glad to have heard the two presentations before me, because this was actually setting the scene for my small talk of today. So if you go then to the next, because I cannot share the screen. So as you heard, so my name is Roberta Mugellesi. I'm belonging to this Space Solution Group. So for today, the talk is to present the call that will go out in March. And in order to do this, I need to have a couple of slides to introduce our team. So this is a Space Solution. So the ESA Space Solution is a group that is actually dedicated to the development of application services using space technology. So what we try is to support the user community and industry to develop innovative services, applications which use space technology. So Space Solution tend to be one of the largest space innovation network in the world, and is the go-to place for creating new business which involve space to improve everyday life. So what we are doing, maybe come back one moment, what we are doing is to support a European company, and this can be startup, SME, or bigger company, to develop the application and using space technology and data. Now going to the next. So ESA Space Solution quite quickly has provided, let's say, 3 major entry points, which is the ESA Business Incubation Center, the BIC, that was also mentioned for Greece, the ESA Technology Transfer, and the ESA Business Application. So the ESA BIC quickly is to help a startup and a young company, let's say, to develop a concept, an idea. The technology transfer support the identification of space technology, which can be used to meet the needs of no space application. And the ESA business application, where we belong, support the development of sustainable services using space asset. And now going to the next. So what we are offering is zero equity funding, so from 50 kilo euro for a BIC to, depend on the project. We are providing technical support to the company, so technical support to develop sustainable solution services, which can then later commercialize. So we pay attention to the business case, and also that the service create a positive socioeconomic impact for the people. And let's say we provide the company access to our network of partners and also access to our network of investors. Now going to the next, and this is, let's say, just the last one introducing our program. Basically, we have been active in many different domains. We are existing since more or less 2009, and we have done a large number of projects. Can be pilot, can be feasibility study or short feasibility study in different domains. So we have tackled a lot of different domains, and you see here maritime, healthcare, transport. So you can see here a number of names of different domains. And what we are doing is we are supporting the development of new applications. So where there is a need to involve space technology to innovate the business, providing space to provide the benefit to the application. And this can be Earth observation with the images or meteo data, space weather, and so on. Can be satellite navigation information for positioning, geolocalization, or can be satellite communication as a backup when the terrestrial network is not available or there is a failure to increase the robustness, resilience of the network. Now we are moving to the core of this talk, which is about an announcement of opportunity. So this is, so it's not an invitation to tender, it's an announcement of opportunity, which will go out mid-March, so next month. And I've been working on this for, let's say, a few months. So the title of this announcement opportunity is Space for Smart and Uncrewed Shipping, Downstream Services Enabled by 5G and Advanced PNT. So basically this announcement opportunity aims to support the development of space-based services and solutions relying on 5G and PNT in the domain of the smart and uncrewed shipping. So the proposal submitted in the context of this announcement opportunity shall address one or more thematic areas which are related to this domain. Of course, there are also other space terrestrial assets, but also technology like we know very well artificial intelligence, machine learning, and so on, which may be relevant for implementing the service concept. And this indeed can be integrated in the service proposition. Now, it is also, maybe in the context of today, is also interesting for you to know that in order to prepare this call, several consultations with different stakeholders have taken place during the last months in order to define this call. And our major stakeholder can be classified in different categories. So we have alliance like industrial association like 1C Alliance. We have been talking with government agency like, for example, the UK Department of Transport and the Finnish Traficom. Of course, we are talking with the European Maritime Safety Agency. We are talking with the other maritime authority, like, for example, very interested in Norwegian one maritime authority, or let's say the Port Network Authority of the Ionis Sea in Italy. We have a port authority on board, also in Italy, Port of Bari, Port of Taranto, we have Rome, Venice, we have the British Port Association, and so on, and several research centers. Very interesting was also the discussion with the German Research and Institute, where let's say, indoor simulation, outdoor test field for this autonomous and uncrewed shipping is either planned or it's already somehow taking place. So from this discussion with the stakeholder came out, maybe you can come back to the previous one, basically came back 2 points, that the stakeholder from one side, they want to support, let's say they are looking space to support the emergence of these commercially sustainable services in this domain, so smart and crew. But also another important point is to integrate, so to advance in the integration of this uncrewed vessel in the general traditional maritime traffic. And therefore we have this sub-team, so based on the discussion, we have identified this sub-team, this 4-1, that are, let's say, explained also as a material in the announcement of opportunity, and I have basically one slide for each of these. Now going to the next, we start with the first one, which is towards shipping 4.0. So here, let's say, possible application here in this digitalization, as we have heard, is could be inclusion, for example, near real-time monitoring of port capacity, but also for the container with the help of Earth observation images interpreted with machine learning algorithm, for example, to identify, to make statistics, stochastic prediction of the number of shipping container, for example. The next one, for example, is, and this is also very interesting that we got the same needs, so to develop a predictive, so we are talking about a predictive digital maintenance solution, for example, for vessel and shipping. And in some cases also came out that stakeholders are interested in a more cost-efficient monitoring, for example, of the seabed cables and the pipeline, utilizing exactly the maritime autonomous surface ship, but operated via SATCOM or SATNAV. Another one is the support to efficient remote operation at sea. This basically is a real-time monitoring of cargo of the container. So basically the container can be equipped with specific sensor that monitor the temperature, humidity, and so on. And all this can be then secure and transmitted with blockchain satellite link, and the data are transmitted. Now, going to the next, still on the towards shipping 4.0, another point is also the uncrewed shipping for inland water. This was also something specifically came during the discussion with our German stakeholder, so inland water and the short-term shipping. So this included, for example, also autonomous operation of, for example, crane in the port, utilizing, for example, port maps created by Earth observation, also with the help of digital twin, but again with the machine learning and a satellite link by which the operation can be monitored and controlled. And then we have the safe autonomous navigation and operation. And this basically includes the remote monitoring and operation of the autonomous vessel by combining blockchain security and 5G with the satellite link, as well, let's say, satellite positioning to achieve a more accurate and reliable navigation. It's also interesting. Another point is also to include an analysis and monitoring for the prevention of a ship collision, specifically in those areas which are very dense, and this means continuously monitor position and course of the vessel, but also inform the ship, the port authority, and the port manager of possible course correction. Okay, this was the first. Now going to the second one. Now the second sub-team that we identify, and of course we needed to group together the material, is the monitoring of the coastal area. So monitoring of the coastal area included this three major points: the detection and the monitoring of this threatened coastal area. For example, this include, for example, detection of source of illegal pollutant which are then along the coastline, and this again through Earth observation images, but also satellite navigation with data from camera and sensor on board of unmanned, for example, maritime or surface and let's say UAV. Another one is also monitoring the land and the water infrastructure in the coastal area. For example, this include assessing and also mitigating the effect of this coastal dredging, but also the coastal erosion, and also see how they impact on the submarine ecosystem due to the several and very traffic area. And this again done through Earth observation data in combination with the remotely, with the UAV, but also with the watercraft. And the third point is mitigating climate change impact risk on the human and natural capital along the coast. So this means monitoring, mitigating effect on coastal erosion, using a map, up-to-date map created from Earth observation images, reading from sensor, and let's say making use of 5G and GNSS for reliable communication navigation. Then going now to the third thematic area. So this is maritime surveillance. So this possible application that can be tackled by the bidder, not by the bidder, by the contractor. This include, for example, surveillance of maritime traffic. This may include, for example, the debris from vessel which wrecked vessel, using again high-resolution satellite images, data from remotely piloted aircraft, weather data, and then collecting all this data in a central dashboard utilizing machine learning to predict also how this debris can spread. This is just an example of surveillance maritime traffic. Another one is still the detection of illegal action related to illegal fishery. This we have to tackle in the past, but here now it's not only preventing, monitoring this illegal fishing, but using this, let's say, more up-to-date technology, using machine learning, for example, to interpret and using machine learning for the satellite image to see how, let's say, identifying the boat to make, let's say, prediction, and again, following by the boat with deployment of, again, remotely piloted aircraft on a regular patrol. And then also the detection of oil spilling, environmental pollution. This is again something that we have tackled in the past. This means detecting, tracking liquid waste spill by the ship using satellite imaging, camera, radar data, but again, transmitting a lot of data with the 5G and using, let's say, machine learning, artificial intelligence, through which the collected data can be, for example, compiled into more comprehensive, updated, and integrated, into a GIS system. And now going to the next, we are at the last of the sub-thematic area, which is the environmental sustainability. And here, the contractor that they are making proposal can include several items. They can include, for example, reduction of emission, environmental footprint of maritime thanks to weather and oceanographic data, can, for example, include the support to offshore decommissioning, renewable, for example, plant installation, operation at sea, can include the monitoring of, let's say, the monitoring the water quality along the shipping route. For example, this can be done using ESA, ocean color services, in combination with other sensor, other equipment on board of this UMS, and of course collecting data also from camera and UAV. But also the monitoring of marine protected area for the preservation of the biodiversity. So monitoring also the state of the aquatic animal population in the seabed plant life, for example, in the vicinity of very frequent shipping route, again in combination with observation and without data. So these are, let's say, 4 sub-thematic areas. The contractor in their proposal, they can tackle one of these, they can tackle more of these, depending on the proposal. Now, let's say, going to the next slide, this is only that we are, let's say, very interesting to see also the technology that can be associated. So when we are talking about 5G, it's not only the terrestrial 5G. We want to see 5G in combination with the satellite communication. For example, in area where you don't have a terrestrial communication, how, let's say, this can, let's say, all this data can be, let's say, brought and, let's say, given and provided. And now, why it's important, the role of 5G is because of the low latency, because of the high reliability of data, to support also the autonomous shipping, providing this high throughput data. We see 5G also used already in some part for port operation logistic, also because application including digital twin of the port, making use of augmented virtual reality or a massive IoT. So there is an enormous amount of data that have to be distributed, support port operation and with automation, the cargo, and and the augmented immersive reality, which I've already mentioned. So we are, let's say, this is a call that will go out, as I said, mid of March, and now we are at the point to, let's say, to finalize, let's say, the last administrative step before, let's say, this announcement opportunity will be published on EMITS. And this concludes. So if you go to the next, thank you for having me, for giving the opportunity to present this announcement opportunity. If you have more questions, of course, this is the email. You can contact me, and let's say still we can talk until the call will go out on the 17th of March. So if you have a question before that, you can contact me, and after that, of course, you have to pose your question in the ESA online system. Thank you. And thank you, Eurisy, for having organized this very interesting webinar.
Thank you very much, Roberta, for your very informative presentation on this call for opportunities. So to all the companies that are here connected today and that are working to develop solutions in this field, do not miss this chance to apply. So I would like to open the floor for a couple of questions. We are running quite a bit out of time. But I see here that, somebody is asking to Orpheus about the availability of the Greek catalog. So I don't know, Orpheus, if you want to tell us something, if it's a confidential report or if it could be found on the website of Coralia.
Oh, sorry, I changed locations. Let me turn off the camera. Okay, can I share my screen? Would you mind?
Yeah, sure, please.
Give me a second. Okay, I hope you can see my screen, and I'm sorry for the pause at the presentation. In any case, you can find online the version of the Greek Space Catalog from 2018. Since this catalog has a lot of work and it's also related to the business plan of the SI cluster, the latest versions are confidential, but if you want to have the updated version, depending on the context, you will need it. You are free to contact us in this email or at the email of the SI cluster.
Thank you very much, and you might receive some requests. So I think that it's time for us to close the webinar. I do not see any additional question. I would like to wrap up by saying that after the very interesting presentations of the speakers today, we can see a lot of potential for satellite data sets to actually supplement and to, let's say, provide a reliable data for solutions that can really address some of the needs in terms of, again, both optimization of processes as well as economical benefits in terms of, as Mr. Faraone showed earlier, reducing the number of people on the ships. We saw that there is a lot of different activities going on in this domain, from the support to companies that are working on the sector to indeed grow their solution into some operational products. And I hope that this information have been useful for all of you. I would conclude by thanking again all our speakers for the very interesting insights provided today to the audience. The presentations will be made available on our website, and we invite all the attendees to follow the third webinar of the series about marine special planning. I thank again all the speakers today, and I wish you everybody a great evening.
Thank you, and goodbye. Thank you.
Thank you, Annalisa. Bye, thank you all.